Auzu billahi minash shaitani rajim. Bismillahir Rahmanir Rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar. Dear students, today in this first video lecture of first week for the course Applied Mathematics 1, we are going to learn about function and limits. Dear students, first of all, I would like to tell you about the difference between relations and functions. Relations and function is the most important topics
In mathematics. These are the two different words having differing meanings mathematically. You might get confused about their difference. Before we go deeper, let's understand the difference between both with a simple example. An ordered pair. First of all, dear students, note that what is an ordered pair? Ordered pair represent as input and output. Relation shows the relationship between input and output, whereas a function is a relation which derives one output for each given input. So this is the main difference between relations and functions. So every function is a relation, but it is not necessary that every relation will be a function. So a function actually is a relation, but for the function it is the condition that one output for each given input. A function is a relation which derives one output for each given input. All functions are relation, but not all relation are function. Like you see over here, dear students, note that in this figure, this whole circle represent a relation. But in this relation, there is a sub-relation for this relation, which is represented by the yellow color. So this yellow color relation is a function. And in this relation, there will be one output for each given input. So this is the a function. And this is the main difference between the relation and the function. Now, a function is a relation which describes that there should be only one output for each input. Or we can say that a special kind of relation mean a set of ordered pairs which follows a rule which follow a rules, that is, every x value should be associated to only one y value is called a function. For example, dear students, you see over here this the data of this table is very simple. It's very simple. This is the domain for a function -1, 1, and 3. So for this domain -1, for this domain there exists a range -3. Similarly, for domain 1 there exists a range 3, and for domain 3 there exists a range 3. So now this is the function, because for every domain there exists a unique image. So if for every domain there exists a unique image, then the relation will be called a function. Let us also look at the definition of domain and range of a function. Domain. Uh, it is the collection of the first value in the ordered pairs. Like for example, you see over here, this is the relation -1, -3, 1, 3, and 3, 9. So the first elements of the ordered pairs are the domains, and the second element of the ordered pairs is the range. So what is the range? What is the range? It is collection of all second values in the ordered pairs, set of all output. So set of all input, set of all output is called the range, and set of all input is called the domain of the relation or the domain of the function. In this relation, like you see over here, this is a relation -1, comma 3, 4, comma 5, 6, -5, -2, and 3. So this is a relation. And this, if this relation is a function, then for each domain there exists a unique image. For example, for -2 the image is 3, for 4 the image is 5, for 6 the image is -5, for -2 the image is 3. In other words, we can say that for the domain -2 there exists range 3, for the domain 4 there exists range 5, for the domain 6 there exists range -5, and for the domain -2 there exists the range. So the domain of this relation are -2, 4 and 6, and the range is -5, 3 and 5. Now this is the function. Now the types of functions. The first type of the function is called one-to-one function. One-to-one function basically denotes the mapping of two sets. A function g is one-to-one if every element of the range of g written as one-to-one. A function f is a method which relates elements or values of one variable to the elements or value of the another variable in such a way that elements of the second variable is identically determined by the elements of the first variable. With the help of example, we are going to learn about this function in detail so that its concept could be easily understood. So dear student, first of all note that for a function, uh, for each domain there will be exist a unique image. So the relation will be a function. Now you see over here, these are the domains -1, 0, 1 and 2, and these are the range 0, 1, 2 and 3. So this is the example of one-to-one function because for -1 for domain -1 the range is 0, for domain 0 the range is 1, for domain 1 the range is 2, and for domain 2 the range is 3. And this x goes to x plus 1. So x maps to x plus 1. So f of x is equal to x plus 1. So this is the function for these domain and range. If we put x is equal to -1 in this function, we obtain the range is 0. And if we put the domain 0, the range will be 1. If we put the domain 1, the range will be 2. If we put the domain 2, the range will be 3. So this is one-to-one function. Now, onto function. Onto function, sometimes called surjectio function. Onto function could be explained by considering two sets like set A and set B, which consists of elements. If for every element of B there is at least one or more than one element matching with A, then the function is said to be onto function or surjectio function. The term for the surjectio function was introduced by Nicholas Bourbaki. For example, you see over here, this is the surjectio function. X map to 1, Y also map to 1, and Z map to 2, and W map to 3. So this is the surjectio function, and this is actually called onto function. Similarly, in this figure number 2, X map to 1, Y map to 1, and Z map to 2, W map to 3. But for this range 4, there is no domain. So this function is not the surjectio function. This function is not onto function. Now, bijectio function. A function is said to be bijectio or bijection if a function f from a to b satisfied both the injectio mean one-to-one function, and surjectio mean onto function properties. It's mean that every element b in the domain b every element B in the domain B, there is exactly one element A in the domain A, such that f of A is equal to B. If the function satisfied this condition, then it is known as one-to-one correspondence. Like you see over here, uh, for domain 1A, there exists range B. For domain 2, there exists range 4. And for domain 3, there exists range 9. So this function is a bijectio function. Now, dear students, the next topic for this course is the limit of a function. Before the limit, we have discussed the function and its domain and range. So, dear students, for a function, for each domain, there will be exist a unique image. Then the relation will be called a function. So sometime when we identify the domain, then first of all find the range, find the domain area, and putting the domain in the function, we can calculate the range for the function. So in this topic now we are going to learn about the limit of the function. Suppose if be a function defined on some open interval that contains the numbers a, except possibly at a itself, we say that the limit of the function f of x. F is the function and x represent the independent variable. Actually, sometimes domain called independent variable and range called dependent variable. So for this function now, f is a function and x is domain, x is an independent quantity. And as x approaches a is L, and we write as limit x tends to a, f of x is equal to L. If for every number epsilon greater than 0, there is a corresponding number delta greater than 0 such that absolute of f of x minus L less than epsilon whenever absolute x minus a greater than 0, L less than delta. So this is a very basic definition for the limit of a function. Now there are some laws for limit when we calculate the limit for the function. So these laws indicate that how to apply a limit for a function. And sometimes there will be undefined limit form like 0 by 0 form, infinity by infinity form. So in the coming video lectures, we will discuss how to define the undefined limit. Now all these are the laws, these are the laws for the limits, how to calculate the limit of a function. For example, L, M, C and K are real numbers, and limit x tends to a for the function f of x is equal to L, and limit x tends to a for the g function where x is the domain for the g function also, and this is equal to M. Now the first law, if we put limit x tends to a for any constant c, then we obtain in the result that constant c. It's mean that the limit of a constant real number is that number. And law number 2, limit x tends to a for the function f of x is equal to f of a, where this f of a now will be a polynomial. For example, we have a limit x tends to a for the function. It's mean that just put x is equal to a in the function. The limit value of a polynomial is the function value at that point. Now, another law, number 3. For example, one constant number and function are multiplied. Then how to apply the limit for this situation? C limit x tends to a for the function, we can write C into limit x tends to a for the function. It's mean that put only limit for the function. Put only limit for those terms which contain the domain x. C is constant. The limit of the product of a constant and a function equals to the constant times the limit of the function. Now, if two functions are in the sum are in the form of sum or difference, then how to calculate the limit in this form? Limit approaches to a, limit extends to a for the function f of x plus or minus g of x. Then put the limit for the f function plus or minus put the limit for the g function. Limit extends to a f of x plus minus limit extends to a g of x. The limit of the sum or difference, it's mean that the limit of the function or difference of two functions equals the sum or difference of the limit of the functions. Now another law, number 5, limit x tends to a f function dot g function. So we can write limit x tends to a for the function f dot multiplied limit x tends to a for the function g. It's mean that the limit of the product of two functions is the product of the limits of the functions. And another law, number 6, limit x tends to a f of x divided by g of x. So we can put limit x tends to a for the function f of x divided by limit x tends to a for the function g of x. This law means that the limit of a quotient is the quotient of the limits of the numerator and the denominator if the limit of the denominator is not 0. This point is very important. Dear students, in the coming slides, we will discuss limits of this form. Sometime limit of these form does not exist. So we will try to define the undefined limit. So this is the main question, that how to define undefined limit. So dear students, you see over here law number 6, limit x tends to a f of x power n. Then we can write limit x tends to a f of x whole power n, provided this is defined. And it's mean that this expression mean that the limit of a function rise to a power equals the limit of the function rise to the power, provided the maths make sense. Now, there are some problems related to limits of the function, how to apply the limit, how to evaluate the limit x tends to 1 for the function x square plus 2x plus 4. Dear student, actually this limit means that when you put the domain x is equal to 1 for this function, that what will be the range. Actually, we are searching the range for the domain x is equal to 1. So when we put x is equal to 1, this will be the function value, but this is actually the limit of the function. Limit goes to 1, limit approaches to 1, limit extends to 1 of the function x square plus 2x plus 4. Now, using the previous laws which we have already discussed, uh, these functions are in the sum, are in the form of addition. So first of all, applying the limit for x square, then applying the limit for 2x, and then applying the limit for 4. But since 4 is a constant, so we cannot put x is equal to 1 limit in this term, constant term. Now just put limit x tends to 1 for the term x square and limit x tends to 1 for the term 2x. Now putting x is equal to 1, uh, putting x is equal to 1 in this term, we obtain 1 square plus 2 into putting limit x is equal to 1 in this term and write 4 as it is. Now 1 square mean 1, 2 1 the 2 and plus 4. 1 plus 2 plus 4 is equal to 7. So dear student, this is the function value. So for the domain x, there exists range 7 in this function x square plus 2x plus 4. Now another problem, how to evaluate the limit for the function limit x tends to minus 2 x cube minus 2x square plus 4x plus 8. So dear students, using the previous laws, these functions, this and this function terms are in the form of addition, like you see over here x cube minus 2x square plus 4x plus 8. So put the limit for x cube, put the limit for minus 2x square, put the limit for 4x, and 8 is the constant term. So we cannot put the limit x tends to minus 2 in this term, because 8 cannot 8 does not contain the domain x. So we cannot put limit x tends to minus 2 in this constant term. Now just putting the limit for the term x cube, putting x is equal to minus 2 in this term, putting x is equal to minus 2 for the x square, and putting x is equal to minus 2 for the limit x tends to minus 2 of x. Now dear student, you see over here minus 2 power 3 mean 8, minus 2 square mean 4, and 4 to the 8, and 2 for the 8 again. Now you see over here plus 8 minus 8 cancel, and minus 8 is equal to minus 16. Now another problem, to evaluate the limit t tends to 6, 8 into t minus 5 into t minus 7. So this is the previous law, like you see over here in the previous slide. We have already discussed law number 5. When two functions are in the form of product, then just put the limit of the product of two functions is the product of the limits of the function. So put the limit for the function. This is the product of the limits of the function. So in this problem you see over here, put the limit for t minus 1 and put the limit for t minus 7. So 8 into limit t tends to 6 for t minus limit t tends to 6 for 5. But since 5 is the constant term, so we cannot put t is equal to 6 in this constant term. Now for the another factor, limit t tends to 6 of t minus limit t tends to 6 of 7. But since 7 is the constant term, so we cannot put the limit t is equal to 6 in this term because this is the constant term. Now putting the limit 8 into 6 minus 5 into 6 minus 7, and after simplifications we obtain 8 into 1 into minus 1, which is equal to minus 8. Now dear student, this is actually now law number 5. In the previous slide you see over here, when two functions are in the form of division, so this is the quotient, f of x divided by g of x. Now you see over here, y plus 2 divided by y square plus 5y plus 6. Now limit, we put limit for the numerator and we put limit for the denominator. Like you see over here, limit y tends to 2 for the y plus limit y tends to 2 for the 2. But since 2 is a constant term, so we cannot put the limit in this term. Now dividing by limit y tends to 0 for y square plus limit y tends to 0 for y, and 5 plus 5 into limit y tends to 0 for y plus limit y tends to 0, 2 for 6. But since 6 is the constant term, so we cannot put limit in this constant term. Now putting the limit, you see over here, this is the value of y plus 2 divided by y limit is 2. So 5 into y mean 5 multiplied 2 plus 6 is it is. Now 2 plus 2 4, 2 square mean 4, 2 5 that 10, and 6 is it is. Now 4 divided by 20 actually equal to 1 over 5. Now, another problem to evaluate the limit z tends to 0 for the function 2z minus 8 whole power 1 over 3. Now, dear students, this is actually the law number 7. In the previous slide, you see over here, law number 6, sorry. This is law number 6. Limit x tends to a for the function f of x power n. So, first of all, put the limit and then evaluate the power for the function. And the limit of the function rise to a power equals the limit of the function rise to the power, provide the math makes sense. So, dear student, first of all, put the limit and then evaluate the result according to the power. Now putting z is equal to 0 in this term, putting z is equal to 0, this term will be 0, and putting z is equal to 0 for the 8, but since 8 does not contain the domain z, so we cannot put this limit for this constant term. Now we obtain minus 8 power 3, and minus 8 mean minus 2 power 3 and whole power 1 over 3. 3 and 1 over 3 cancel, so the result is minus 2. So it's mean that for z is equal to 0, the range of the function is minus 2. Now to evaluate the limit x tends to minus 5, x square plus 3x plus minus 10 divided by x minus x plus 5. So dear student, now this is the main very important limit. This limit is actually undefined limit, because when we put minus 5 in the denominator, we obtain in the denominator 0, and any numbers, any non-number 0, any non-zero number divided by 0 will be undefined, and 0 divided by 0 is also undefined. So now this is actually undefined limit, and you see the solution on the next slides. You see over here, if we put the values of the limit in the function, so it gives the result as an indeterminate form. Like you see over here, if we put x is equal to minus 5, so if we put x is equal to minus 5, like you see over here, so for x is equal to minus 5, minus 5, if we put x is equal to minus 5 in this term, if we put x is equal to minus 5 in this term, minus 5 plus 5 will be 0, and minus 5 square mean 10, minus 5 square mean 25, and minus 15, 25, 25 minus 15 plus 10, plus 10 minus 10, 0. So this 0 by 0 form actually indeterminate form. So this is the undefined form. So now we can define this undefined limit by using some mathematical process. So first of all, factorize the numerator. To factorize x square plus 3x minus 10 by factorization by sum and product. Factorization by sum and product mean that first of all multiplied the coefficient of the first term, multiplied the coefficient like you see over here. This is the coefficient. So first of all multiplied this coefficient and minus 10, we obtained minus 10. Now choose two numbers. Choose two numbers which represent choose choose two numbers that suppose 5 and minus 2. These two number when we multiplied these two number we obtained minus 10, and when we add these two number we obtained plus 3. So for the factorization by sum and product, this is a very simple process that first of all multiplied the coefficient of the first term in the denominator like you see over here. Actually x square is the first term in the numerator, so the coefficient of this term is 1. So first of all multiplied 1 and minus 10, we obtain minus 10. Now choose two number. So choose that two numbers. By multiplying that two numbers we obtain minus 10, and by adding these two number we obtain plus 3. So this will be the factorization. So if we choose 5 and minus 2, then 5 and minus 2 give plus 3, and by multiplying 5 and minus 2 we obtain minus 10. So now factorize this 3 is 5 and minus 2. Now write limit x tends to minus 5, x square plus 5x minus 2x minus 10 divided by x plus 5. Now taking common x from x square plus 5x, we obtain x into x plus 5, and taking common minus 2 from these two terms, minus 2 into x plus 5 divided by x plus 5. Now taking common x plus 5, and we write limit x tends to minus 5, limit x tends to minus 5, x plus 5 into x minus 2 divided by x plus 5 as it is. Now x plus 5 and x plus 5 are cancelled, and we obtain limit x tends to minus 5 of the x minus 2. Now putting the limit for x minus 5 minus 2 is minus 7. Now the limit is defined, but in the initial stage the limit is undefined. But when we factorize the numerator, when we simplify the question, so when we simplify the problem, then the simplest form of the problem is limit x tends to minus 5 x minus 2. Now this limit actually is exist. Now another problem to evaluate the limit x tends to minus 1 for under root x square plus 8 minus 3 divided by x